This video covers slide scanning in Brightfield. It's a good idea to familiarize yourself with general imaging in Brightfield first, so check out that video if you haven't already, and then come back here. Begin by placing a reference point and getting a live image. Use the joystick to move over the region that you want to image. Go to the Trace ribbon, and then choose the contour type that you want to acquire. It's a good idea to use freehand contour mapping, although you can use circle or square if you want to acquire a scanned image that's a circle or a square. With your contour selected, begin tracing around your region of interest. Remember that you can right-click to choose simple click tracing, rubber line tracing, or continuous, which is click and drag tracing. Rubber line gives you a preview option. If your region of interest contour is larger than a single field of view, go to the Workspace tab and choose Define Auto Move Area. Define your auto move area with 2 clicks, and then you can click outside of the white dotted auto move box to trace more than one field of view. Once you finish tracing your contour, right-click and choose Close Contour. You can trace this region of interest contour at any magnification, but usually it's quickest and easiest to do it at the lowest magnification where you can reasonably see your region of interest. Once you're finished, go up to the magnification that you want to scan your slide at. If you're working at 10x or above, it's important to go through the process of color illumination. Also, adjust your camera settings and white balance the image. Don't worry about getting it perfect just yet. We'll need to take a background image before we can start scanning this slide. A background image helps correct for tiling issues. Using the joystick in Joy Track mode, move off your tissue to a blank area of the slide. Adjust your camera histogram so that it's a single thin spike. Note that if you can't get a single thin spike, chances are you have dust or another artifact somewhere on the screen. It's okay to cheat and use the focus to help remove that artifact. Then further adjust your exposure time to move the camera histogram spike as far to the right as you can possibly get it. One quick note here. File, Hardware Setup, Camera, Fit Video and Window should be turned on when you're taking a background image. Otherwise, it's possible that you could have artifacts off screen that you can't see. Once you're happy with how your background image looks and you're sure there's no artifacts on your screen, go to the Acquire tab and choose Acquire Background Correction Image. You want to pick Brightfield Background Image and enable multi-channel correction. Then click OK. Your background image will be taken just like any other and show up in the image organizer as an unsaved image. There's no need to save your background correction image though. Let's go to the Acquire tab and choose Live Image to return to the Live Image preview. Now we can use the macro view to return to the area that you want to scan. Just right-click, pick Go To, and then click to center your screen on an area. We'll need to refocus on your tissue. It's important to not make changes to the exposure time or light level on your microscope once you've acquired the background image. If everything looks good, we're ready to begin scanning this area. From the Acquire ribbon, choose Scan Slide. If you forget where this option is, remember that you can always use the quick launch and type in Scan to find it. There are 3 options here. Grid will begin at your current field of view and then move to the right and down by how many fields of view you specify. Contour only inside and all tiles will use the region of interest contour that we traced earlier and are only available if you have a closed contour traced. Here I've acquired the same contour with all tiles on the bottom and only inside on the top. You can see the difference. Type option allows you to select either 2D, that's a single plane image, or 3D, that's a series of tiled image stacks. Note that the 3D option is only available if you've purchased the 3D slide scanning module. Under Scanning Options, you typically want to have Keep Image Open turned on. This will open the image as soon as it's been acquired. Under Trim Blend Options, the default settings usually work pretty well. We generally want to get rid of the pixels that are around the edge of the camera chip, and sometimes you want to turn on Blending. This will fade out pixels around the edge of each tile and fade in pixels on the adjacent tile. While it looks like these options would be a good way to correct tiling issues where you can see the individual tiles of your scan slide, they're actually not. If you can see the individual tiles once you've finished acquiring the image, chances are that's a calibration or camera stage alignment problem. Check out these videos to fix it. Once you're happy with how your settings look, click OK to save the image and start scanning. There are a couple formats available, MBF JPEG 2000 and TIFF being the most popular ones. Type a file name and click Save. If you have more than one contour, you'll be prompted to select which contour you want to acquire on this step. Just click to select a contour. Once you've selected at least one contour for scanning, you'll see this grid appear. That will give you an idea of how many tiles you'll have in your virtual tissue. You can either hold the Shift key on your keyboard and click to select sites to pre-focus at, or you can right-click and choose Add to Focus Site List. There's also the option to randomly select focus sites. The number of focus sites that you need is dependent on how wavy your tissue is and on how high a magnification you're acquiring at. If you're acquiring an entire brain at 2.5 or 5x, you may only need 1 or 2 focus sites. On the other hand, if you're scanning a slide at very high magnification, like 63 or 100x, you might need to focus at as many as a quarter of the total sites that you have. It's a good idea to have a few focus sites at the edge of your tissue and a few in the middle. This focus map looks good. If you place all your focus sites in a line like this, you'll get very nice in-focus images along that line, but you never know what your tissue could do down in this area or this area, and if it moves up or down, you're going to end up with out-of-focus regions. If we add a couple focus sites to this scan slide, we'll have a much cleaner resulting image. Once you're happy with how your pre-focus site selection looks, right-click and choose Focus at Selected Sites. The software will take you to the first focus site. Focus up and down until your tissue is in focus, and then click on Next. Repeat this process for all sites. If you find yourself at a site that doesn't have any tissue at it, skip that site. If you make a mistake, you can use the previous button. Once you're finished, you'll go back to the pre-focus screen. The red numbers indicate areas where you focused, and the white numbers are extrapolated values that the software has calculated. If everything looks good, right-click and choose Start Scanning Slide with Prefocus. The software will go to each site, acquire an image, and then stitch them together. Depending on the size of the image and the number of tiles that you have, this process may take a while. Once the scan finishes, the software will automatically zoom to fit your whole data file on the screen. If you want to zoom in and just see that slide that you scanned, click on the Zoom In button, and then click and drag a box around your image to zoom in. You can also zoom in further and check for tiling artifacts like seams being visible. This image looks great. I don't see any apparent seams, and I'm happy with the image quality. But things don't always look perfect. On this image, I either didn't take a background correction image, or maybe there was an artifact like a piece of tissue or a part of a shutter in my background correction image. Unfortunately, there's no way to remove this type of artifact after acquisition, so I'd need to figure out what the problem was and then reacquire this image. Typically, problems like this with an artifact present in every single frame are caused by problems with background correction. Look closely and make sure that your cells align on the seams between tiles to make sure this isn't a camera stage alignment problem. This image looks okay from a distance, but when we zoom in on it, you can clearly see seams between the tiles. This type of doubling problem is usually caused by either calibration or the camera stage alignment. Check out these videos for more information. If the tiles just don't match up at all, there's a good chance you had the wrong lens selected.